In today's lesson, we're going to look at some examples of circle theorems. Now, the question before us says that we should find the missing angles in the diagrams below. And the first diagram we have is this. And the missing angles are labeled Y and X. Now, this is a circle, and we have a quadrilateral inscribed into the circle. So we'll call this a cyclic quadrilateral. That's the name of this shape. It has edges A, B, C, and D. Okay, now how do we find Y and how do we find X? In our previous lesson, we looked at different theorems of circle, about 10 theorems of circle. And to find Y and X, we will apply theorem number 6. This is it, theorem number 6. What does it state? Circle theorem number 6 states that the sum of the opposite angles of a cyclic quadrilateral is 180, or angles in opposite segments of a cyclic quadrilateral are supplementary. Of course, supplementary angles are angles that adds up to give you 180 degrees. So when two angles adds up, it gives you 180 degrees. So in that lesson, in the previous lesson, we're able to establish that when you have a cyclic quadrilateral like this, that the angle here plus the angle here will be equal to 180 degrees. Likewise, the angle here plus the angle here will be equal to 180 degrees, following this very rule. So we're going to apply this rule to find the value of Y and the value of X. Following theorem 6, Y plus 57 are opposite to each other. So this is opposite to this. And 45 is opposite to X. So I will add up 57 plus Y, and it's going to give us 180. Following the rule, they are going to be supplementary. So it follows that Y plus 57 is equal to 180 degrees. So Y is then 180 minus 57. And when we do this subtraction, we'll carry out this subtraction, we have Y to be equal to 123 degrees. So it's as simple as this. So we've gotten the value of Y to be 123 degrees. Alright, what about X? Following the same rule, the rule is saying that when you have a cyclic quadrilateral, that the sum of the opposite angles will be equal to 180 degrees. So it means that X plus 45 equals 180 degrees. So we can easily find our X. That is X plus 45 degrees is equal to 180 degrees. That is our supplementary angles. Then X is equal to 180 minus 45 degrees. And my X then is giving me 135 degrees when you carry out the subtraction. So this is basically what you have as the value of X. So when you have a cyclic quadrilateral, theorem number 6 is what you will use. So take note that the opposite angles are going to be equal to, when you add them up, is going to be equal to 180 degrees. Okay. All right. Let's look at the next question. The next diagram we have here is this. This is the next diagram we have. We have a circle and we have something like a triangle, and we are asked to find theta. So theta is the angle we are required to find. Now, what law are we going to apply? What theorem of circle are we going to apply to find this very angle? So I would like you to take note that this point here is the center of the circle. So I can label here O. So this very point is the center of the circle. Okay, so this is going to be the radius of the circle, meaning that this will be equal to this. This line will be equal to this very line. Now, there is a theorem we looked at in our previous lesson, and that is theorem number 3. This is it, theorem number 3. This theorem states that the angle subtended by an arc of a circle at the center of the circle is twice the angle it subtends at any other point on the circumference. So the angle subtended by an arc, this is the arc we're referring to here. So the angle subtended by an arc of a circle at the circumference, this is the angle subtended at the circumference by this very arc. So we established that this very angle here, that when we multiply the angle at the circumference by 2, is going to give us the angle at the center. That's what the rule is saying. Okay, but it's important to take note that this very angle at the circumference must be coming from the same arc. So the angle formed at the center is coming from this arc. Likewise, the angle formed at the circumference is also coming from the same arc. So when this happens, the angle at the circumference, 2 times the angle at the circumference, will give you the angle at the center. Or the angle at the center divided by 2 will give us the angle at the circumference, as far as they are coming from the same arc. So the same arc has to form the angles at the center and at the circumference. So this is what we were able to establish, that theta, which is the angle at the center, is going to be 2 times the angle at the circumference, as far as these 2 angles, the angle here and the angle at the center, are formed from the same arc. All right, so we're going to apply this very rule to find theta in this very problem we are asked. Applying that same rule, we have an arc. Okay, this is an arc BC. Now arc BC is forming an angle at the center, and at the same time arc BC is also forming an angle at the circumference, which is 30 degrees. So because the same arc is forming the angle at the center and also forming the angle at the circumference, so following that rule, the angle at the center is going to be 2 times the angle at the circumference, provided that these 2 angles are coming from the same arc. The arc is arc BC. So, which means that we can apply theorem 3, and that means that the angle at the center, in this case, which is theta, is going to be equal to 2 times the angle at the circumference. This is the circumference, so the angle formed at the circumference is 30 degrees. So it's going to be 2 times 30 degrees. Okay, so of course, when we multiply this, we're gonna get that our angle is then going to be 60 degrees. So we've now gotten the value of the angle at the center. Okay, so take note of this rule. This rule is very, very important when we start looking at complex diagrams. Okay, so let's look at the next diagram. The next diagram we have is this. Now we are asked to find, let me put it straight so we can easily see it. Okay, this is it. All right, now we are asked to find x at this that's x. Now what theorem are we going to apply? Look at this very diagram. It appears funny, but it's very simple. Okay, now in our previous lesson there is a theorem we also looked at, and that is theorem number 5, and this is the theorem number 5. We're going to use it to find x. This is theorem number 5. Theorem number 5, what does it state? Now theorem number 5 states that angles in the same segment are equal. Angles in the same segment are equal. That is, the angle at this point is equal to the angle at this very point. Why? Because they are coming from the same segment. Remember, a segment is the part of the circle which is bounded by an arc and a chord. So when you have angles which are formed from the same segment, the theorem is saying that they are going to be equal. So the angle at this point is coming from this segment. Look at it. Look at how the line is running. Okay, it is coming from this segment. They have the same base or the same chord. Likewise, if you look at this let's call it triangle. If you look at it, it's coming from this chord and having the same segment, and it's forming an angle Y. If you also look at this very triangle here, okay, it has the same chord with this very one, and it's coming from the same segment. Hence, the law is saying that when this happens, that the angle here is going to be equal to the angle here. All right, so we're going to apply this rule to get the value of x in this very diagram. Now, I would like you to consider this very segment formed there. Look at this very segment here. This is a segment. It is bounded by an arc and a chord. All right. Now, if you look at this very triangle, it is coming from this very chord and from this very segment. If you also look at this very other triangle, which formed this very angle, it is also coming from this same segment and having the same chord as their basis. Okay, so following that theorem number 5, it therefore means that the angle formed here is going to be equal to the angle formed here. Why? Because this very angle that is formed here is coming from this segment, and likewise the angle that is formed at this very point is coming from this very segment. So theorem number 5 of our circle theorem is saying that when we have this kind of scenario, then the angle that is formed there is going to be equal to the angle that is formed there. So basically, the value of x is going to be equal to 20 degrees. So that is it. Okay, so these rules or laws or theorems are very, very important because we're going to consider complex diagrams in our other lessons. All right, so what have we looked at in this very lesson? In this lesson, we have looked at the first diagram, which we call a cyclic quadrilateral. We said that a cyclic quadrilateral is a quadrilateral, all right, in which its corners are joined by a circle. So this is a quadrilateral. Remember, a quadrilateral is a shape that has 4 sides. So you have one side, this is the second, third, and the fourth one. So it has 4 sides. So this is a quadrilateral, and the edges of the quadrilateral is joined by a circle. Okay, and we followed theorem. I think that was theory number 6 years of circle theorem, which we looked at in our previous lesson, and we say that the opposite angles, when you add them up, is going to be equal to 180 degrees. So that was exactly what we did here. We added up to get the value of y. Likewise, 45 degrees and x are opposite angles, so their sum is going to be supplementary, meaning it's going to be equal to 180. So we established that x plus 45 equals 180 degrees. So we're able to find the value of x to be 135 degrees, and the value of y, we got it to be 123 degrees. And we also looked at the second diagram, which is presented to us, which is given to us here. We're asked to find an angle theta, which is at the center of a circle, and we apply theory number 3, which states that when you have an angle formed at the center by an arc, now this arc is forming an angle at the center, and at the same time the same arc is forming another angle at the circumference of the circle. So imagine we're given the angle at the center, but we're not given the angle at the circumference. All we need to do is to divide the angle at the center to get the angle at the circumference. All right, so this is basically what we looked at. Then we'll move to the last diagram, which is this. We're asked to find the value of x. And what theorem did we apply? We apply theorem 5, which from our previous lesson, theorem 5, which states that when you have angles coming from the same segment, this is the segment, this angle that is formed here in this very triangle is coming from this segment. Likewise, this very angle here, which is formed in this very triangle, that's angle 20, is coming from this same segment. So when we have a case like this, the law says that the angle that is formed here is going to be equal to the angle that is formed here, as far as they are coming from the same segment or from the same chord. All right, so this is what we looked at. So thank you for staying tuned to this very lesson. See you guys in the next lesson. Please hit the subscription button and like the video. Bye for now.